we end up with enough time, we'll do our current wrap-up that says, even if we don't finish completely, I'll do a wrap for the last 15 minutes that have to do with what the implications are of the arguments that we've made so far and what it ought to cause us to do from an evaluation perspective moving forward, because there's a looking backwards and a looking forwards viewpoint that I think are important. Let me set an alarm here. Well, we basically outlined from last time, that we were only really treating one portion of the fine-tuning of the universe. And the thing I had picked was the initial low entropy condition. The reason I picked this one is that it's the biggest number, the biggest single number involved in this kind of stuff. There are dozens and dozens of things like this. But it's also the largest, or it's the one that's most immune to specifics about the universe. So it doesn't matter whether cosmic inflation occurred. It's not dependent on inflation. It doesn't matter with some specifics about whether life is carbon-based or silicon-based or based in some other type of element. It's immune to all of those kinds of concerns. So it's a very generalized approach to that basically just talks about the universe as a system and how what the organization of that system, and maybe to provide a little more, I don't know that I did a good job explaining the major difference. And so forgive me for a minute worth of kind of physics-y explanation, half physics-y explanation, but one of the strongest reasons to think that there was a Big Bang-like event in any case is this cosmic microwave background out there that's at like 2.7-ish Kelvin. That you look around in any direction that you look, you get this basically same temperature with very, very small variations in it in every direction. And that seems to be the result of something like the Big Bang. So if you have that kind of background, the evenness of it is extraordinarily surprising. The fact that in any direction that you look, that everywhere in the universe is related by the same temperature, even though there are portions of the universe now that are outside of causal contact with each other. And the fact so it implies that the beginning of the universe was in a state of near thermal equilibrium where everything was very, very evenly distributed. But the problem with that is when you look at the matter distribution of our universe right now, the one thing it is not is evenly distributed. On the large scales, it is, in that you can kind of take an average at major regions and you'll get something similar. But space is very, you might say stringy or clumpy when it comes, not space, but matter is very stringy or clumpy. You've got these superclusters and you've got this wall and you've got all these huge, huge structures that are tied together in ways that seem to be very much contraindicated by this idea of a very equal system. So it's either on the one end of the spectrum, everything is very, very smooth and balanced and even. On the other, it's very, very clumpy and stringy. The fact that the universe appears to have both features means that it's balanced on this knife edge. It means that if it was a little bit more this way, everything clumps together and you don't get the kind of background that you get. If everything was completely smooth, then there's nothing clumping together and you don't get formations of stars and galaxies and superstructure clusters and structures like that. So it's basically saying the width of the total range of possibilities is out here, and this knife edge on which it's balanced is right here. And when you compare how broad the knife edge is to all the possibilities that are out there from both ends of that spectrum, completely smooth and even in thermal equilibrium and very, very clumpy, that is what yields that big number, and that alone. So, and the good thing about that is it's not unarguable, but the evidence is right in front of us. It's not contentious evidence. There's nobody that is going to say, well, it's not the case that the cosmic microwave background radiation is extraordinarily even. It's not the case that that the large scale structures in the universe are very clumpy. Everybody, I mean, like that's canonical. If you believe in physics at all, you believe in that. So that's one of the strengths of this type of thing. So with that as background, does anybody have any last kind of empirical discussions that they want to have on something like this?
I just want to mention that there have been a lot of papers written by some critics and physicists, philosophers, logicians, arguing against the fine-tuning argument. If anybody wants access to them, I'll be hanging around afterwards and I'll give you the citations to them.
Do you want to discuss any of them here?
You and I have been going around this for like the last week pretty intensely, and it would pretty much heat up the hour.
Sure, but if you want to pick your best shot and give it a shot, and that's what Solid Ground is for. Otherwise, it's just me up here talking. And
If anybody wants access to the papers,
raise your hand if you like just sitting hearing me up here talking. See, no hands. So you sure you don't want to bring up?
I didn't know what you said.
You want to? Why don't you pick the one that you think is the best representative of the best argument against fine tuning? So you can argue against the fine tuning argument, the form of the argument, or you can argue against the one of the premises. Are you saying that one of the premises is not good?
I was just, if anybody wants access to these papers, just see me after the class and I'll give them to you.
Okay. Anybody else?
There are arguments out there.
Yes, but not good ones.
Yeah. But not what?
Not good arguments. Is my point.
Well, that's a matter of opinion.
But the point is, if it's not a matter of opinion, if you assume the stuff that we said to assume in class, which is let's take logic and let's take scientific empiricism and let's take some sort of Bayesian model for saying what evidence is. If you buy those three things, then it's not a matter of opinion, it's a matter of fact. So I will say that Dennis and I have been going around about them. I've looked through the papers, I've read them. One of the reasons I invite it is I don't think any of the papers advance any good arguments. They're very easy. They've already been dismissed by things that we have discussed in class, or there's a couple of very interesting ones where, and I think this is very much how bias, of which of course I'm subject to, informs how we interpret things. But one of the guys in the paper out of the University of Mississippi writes a paper that makes a point about probability that exactly underscores the reason the fine-tuning argument works. But he thinks that it works the other way. But the justification that he uses for that one very, very much makes the point that you would want to make from someone arguing for the fine-tuning perspective. So in any case, by all means, read through the papers, but I think that you'll find that the stuff we discussed in class already interacts with it.
Not to rehash old stuff, but I've been thinking about it this week. So the second question that I had last week about the top number, the numerator, not the denominator.
Yes.
So your point was that would lend itself to the expanding, contracting universe explanation, right? Or the multiverse, and that when it comes down to that narrow neck point, were you saying that it basically resets at that point and everything? Can you rehash that? So
for background to that, remember that when we're doing the probability thing, and this is one of the things that guys brings up in one of the arguments there. This was page 326 to 328 of the Colvin paper. They're saying, well, this fine-tuning argument doesn't work because on any given line, any given set of numbers, you can in any section you can have an infinite number of points in there. So since you can have an infinite number of points in there, of course you're going to get something that's infinitely impossible. But that's just not mathematically doesn't transfer correctly to reality, right? We still say in a dartboard, yes, it's infinitely impossible to hit any point in there. But when you're throwing at a dartboard, you're not throwing at a point. You're throwing at a circle, which is an area. And so you might say, well, there's an infinite number of points in that area. I can divide that area an infinite number of times. Yes, but the bottom line is the dart's still going to hit somewhere. So like the dartboard, you might say, I've got that circle that's some percentage of the entire board. So if I say, I'm going to throw a dart and it's going to hit the board, and that this circle is 2% of the board, if it was a truly random toss, then it would be a 2% chance that it's going to hit this area. And that seems like it should be fine, probabilistically speaking. The same is true here. A number of cards, that's a discrete card. That selection is a discrete number. For this range, so we're talking about a range of values, like the G constant in gravity. We had said that could be anything from the weakest force that we know of all the way up to the strongest force that we know of, that we at least know that forces can have those values. So if we use that as the continuum that we're running on, yes, technically there are an infinite number of points in there, but that's not the argument. The argument on this side, on the entropy condition, is there's a range of entropies, or on the dartboard there is a bullseye. That bullseye, instead of being the size that it would be on a dartboard, now make the dartboard the size of the universe, the bullseye is still smaller than an electron.
Sorry,
Yeah, sorry, but that's getting us to the point of what you're asking.
Gotcha. How do we know that there's not multiple darts? I guess,
And that's what the multiverse hypothesis is entirely designed to give you more darts. So it says, yes, the dartboard is of a certain size. Yes, if you have your number of tries, if your number of tries is 1, then there's something going on here. Like, that's just probably not happening. So everybody agrees with that. That's the reason for the multiverse. The reason for the multiverse is, well, it must be the case then that there are a bunch of more tries.
So they backed it in.
Yes.
They developed the multiverse based on.
Yeah, remember what I said last time is the greatest, some people will argue, no, look, there is no such thing as fine tuning. The best argument that the opposition, so to speak, on the opposite side from what I believe, I'm trying to argue, that the opposition believes that fine tuning exists, is the fact that the multiverse is taken so seriously in cosmology. In fact, you'd be hard pressed not to find somebody in cosmology today who does not believe that the multiverse exists. Like, that's the canonical position now. And the reason it is if you don't, then you end up stuck on one of the horns of, there's 3 horns in this particular trilemma, but you get stuck on, I forgot where our argument is. Oh yeah, but you get stuck, and we know it's, they're not going to say it's necessity. So if someone's saying like, well, yeah, ain't no chance, you're stuck with design unless you go back to chance. So I don't want to do design, so how about multiverse?
So two-part on this one. So
and by the way, it's important to understand, there's literally no other reason for believing the multiverse exists. There's no empirical evidence of it. None. Zero. There's no reason for believing the multiverse exists except for if our universe exists and there wasn't a designer, then it must be the case it's very likely the case, probabilistically speaking, that something like the multiverse exists.
So, probably more of a philosophical question here, but a lot of people get wrapped around the axle with like evolution, right? Like Ravi Zacharias, he said, hey, that's a process question, right? And so, kind of related to this, like, one, what's wrong with the multiverse theory? And 2, let's just take the argument for a minute that the multiverse theory is true. How does that prove there's not a God? Or how does that indicate there's not a God? Or what's to say God didn't use the multiverse to do what he did? Why do they have to be mutually exclusive?
Yes. Well, remember that this is a probabilistic argument entirely. So the other arguments that we've made are not probabilistic arguments. The other arguments we've made are, if these axia are true, then this is deductive. This is a more inductive, this is framed deductively, but there's an inductive step in here that matters. So if the conclusion of this one is really this, the universe exists due to design based on our understanding of probability, and ultimately, if these are the only 3 options. So we've said that there could be a 4th option that we're not talking about here. Nobody knows what it is, or we would have included it in the argument. But if there's a 4th option, maybe there's a 4th option. So ultimately, this is a probabilistic argument. Because it's a probabilistic argument, we are going to have to address it in some way with a notion towards what probably can be and probably cannot be. If you're going to introduce, and some people will say, well, if you're going to introduce a God, you can get anything. That's not technically true. You can only get what's logically possible. So if you say, okay, well, if you're going to introduce a God, you can get anything that's logically possible. But the same is true of the multiverse. Well, if you're going to introduce an infinite multiverse, you get any universe in the world. And the person's like, yeah. So from a preferential perspective between God and the multiverse, at a minimum, they're equal. That a multiverse speculation and a God speculation are the same, in that neither one of them at this point, just looking at this argument, the designer and the multiverse thing, neither one of them have any empirical evidence for them that we've looked for so far. Now we can turn around and say, okay, hang on, maybe there's empirical evidence of a multiverse, let's look for that. Maybe there's empirical evidence of God, let's look for that. When we do that, this is what I was going to say later in class. We've already got good reasons to believe that there could be a designer. You do not have attendantly good reasons to believe that there may be a multiverse. You know what I'm saying? Like the idea that says there could be a multiverse, yes. There's nothing that prevents, in fact, the laws of physics that we know of certainly allow for there to be multiverse. Speculative, but yeah, it's possible. So it's not impossible. So in that sense, the real question is, why is one preferable to the other? Well, you have to go look for further reasons that one would be preferable to the other. And I would simply ask the multiverse proponent, what other reasons do you have to believe that multiverse is not possibly out there? I don't mean possibly, we've acknowledged possibly, is actually out there. Whereas on the God side, you have now made a number of arguments that says God is actually out there.
So even with given the multiverse, all right, let's pretend and say there is a multiverse, still there is an issue of fine-tuning that's involved, because the number of life-permitting universes, possible worlds in the multiverse is still incredibly small. And so if we're only talking about the cosmic background radiation or the entropy of the universe, but if we look at some of the other fine-tuning aspects of the universe, and you start to look at what it would take to create another universe like this one in another realm, say, it becomes incredibly, incredibly small. And so even with the multiverse, there are issues. I wouldn't be afraid of it. I mean, I don't think we can say either there is a designer or there is a multiverse, although I agree there is absolutely zero evidence to say that it's just a possibility. And if you were to take an anthropic type principle and say, well, we can only see this because we're in this universe, then you still have to ask, well, why is it so finely tuned? It doesn't remove the question of why is it so perfect for a life permitting universe. Does that make sense?
Yeah.
Is that reasonable?
Yes, it is. I mean, that I'm like I said, I'm only biting off a portion of it
very
here.
small, but
so the problem is much worse than this for the multiverse proponent. But if you give yourself infinite resources, it's not so much of a problem anymore. So, but you need something like infinite resources. So, as an example, in string theory, which is falling out of vogue now, but in string theory, they tried to put some sort of bound or estimation on how many universes would this allow for, or how many kinds of universes would we expect to find, or something like that. And one of the upper bounds was at something like 10 to the 500th different possible universes under the regime of string theory as a set of physical theories. And but what they found were that the supermajority of a significant portion of those 10 to the 500th power universes are what they call swamp universes, where even under string theory's assumptions, you can't get you can't get them to generate anything like a universe. So it was a theoretical bound, but then when you looked at how it practically worked out, you ended up reducing down to a much smaller number of potential universes.
I guess apart from this, right, whether it's universe or multiverse, like neither one of them, and nothing that science has been able to talk about explains the initial, like, we get initial conditions and all that stuff, but like the initial matter, right? Like even down to I still don't believe you can't completely subdivide a particle ad infinitum, but that's another conversation. Like the initial stuff to make everything, that had to come from somewhere. It didn't just poof.
Right. So your initial question I never really completely answered, did not completely answer, was the neck I was talking about. So consider something like this. Here's kind of we'll make a point here that we're referencing off of. But on the left is some universe collapsing in on itself. And then there's kind of the important point there. Maybe that's traditionally you might see that as this, where there's an actual intersection point, and that's a singular point right there in the middle. That through this neck, my point is, in order for this universe out here with these, galaxies and boy, there's no galaxy that looks like that. Whatever they are, I can't draw. I've left my pen at home. But let's say, some spiral galaxy or whatever. You got all these galaxies in this large scale structure out here and otherwise homogeneous, equal background radiation, et cetera. In order to get this particular entropy condition, that depends on this condition. This condition depends on this condition. And you're getting to lower and lower entropy as you get closer and closer to this point. That point is either a singularity point, like in this X, or it's some neck of a finite size. But the bottom line is at this point, in this region here, that entropy, that level of organization that lets you get the stuff that's on the right is exquisitely small compared to the range of possibilities. And anything other than being in that exquisitely small range doesn't give you a universe with basically matter in it of anything other than, at best, hydrogen and helium. And most of the time, none of that. So if that's the case, remember that each one of these was dependent on the one before it. Well, it's also the case that this singularity or this finite-sized universe is dependent on this state, 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 is dependent on this state. And this doesn't, if you're going to increase entropy, if you're going to decrease entropy, if you're going to kind of turn the clock backwards, and decreasing entropy, by the way, would very much look like, in our universe, time running backwards. That's what decreasing entropy would look like. Eggs, getting into a higher state of organization, books falling back up onto a shelf, not really technically, but heat going back into higher organization portions of their systems. In the box with gas bouncing around, it's the gas that's at thermal equilibrium, and then all of a sudden it all clumps together down in the corner in one weird wipe. Possible, it's possible that can happen. And given an infinite amount of time, the mathematician or physicist will say that will happen if these particles wouldn't decay at all. But in a reasonable period of time, billions and billions of years, that's not happening. And so in the same way, in order to collapse to this high entropy condition, either time has to be running backwards in another universe that's basically coming from a lower entropy condition, a higher entropy condition to a lower entropy condition, in which case that it seems to be empirically identical to time running backwards. And if time's running backwards into here, you have to ask yourself the question, because this was the Sean Carroll point that he debates with Craig, why is that not two universes with arrows of time running in either direction? How are you justified in saying time's running backwards in this universe to hit this point that then runs forward in our universe? What's the difference between that and two universes with a singularity going off in two different directions, temporally speaking? And the point is, there's no reason not to say that that's two different universes starting at the same point. And this is the reason that the multiverse, a infinite regression of universes, either has the same entropy problem or it represents a number of universes coming from a single origin point, in which case you still got an initial big bang. It's just a big bang that creates multiple universes.
Carroll was trying to argue, though, that using that model that there was no beginning to the universe. He wasn't trying to say that there were just two.
Right, but he was making the argument that this arrow of time could be running backwards, that entropy could be running backwards.
He did say that, but he was trying to, his point was, and this may be a ridiculous point, but that there was no beginning because we're just going in two different directions. Well, obviously that still makes a beginning, and that was the problem.
Yeah, and the problem is if the arrow here represents time, and this arrow here represents time, how is that not two universes?
Oh, it is.
Right.
And he was trying to say that, but he wasn't trying to say that it started. He was trying to get away from, which was kind of a ridiculous point.
Yeah, I think my point is that point fails when you consider that it
You're
could
right.
just be two universes. But you're exactly right. That was his point, reason for making the point.
Go ahead.
Oh, thanks. So this one, taking high entropy and making low entropy, that seems completely crazy on the face of it, right? So, we're thinking about this multiverse as this expanding, contracting, but what's to say that there weren't 10 to the 123rd universes that all cooked off at the same time? And one of them won.
That's the multiverse hypothesis. You just stated the multiverse
I
hypothesis.
thought the multiverse was, it's 10 to the 123rd tries, and at some point...
There's nothing that says that has to occur linearly in time.
Okay. So, okay, regardless.
Yeah.
Okay, so then going back to,
Or I don't know of any reason that you couldn't say they all cooked off of this. So this, if you really want to get into this point, this is where it gets hard talking about simultaneity. So if you don't have anything, here's a timeline running over here, here's a timeline running over here. If you can't map one point on this timeline to another point on this timeline, then how are you going to argue what's happening? Let me draw this. So I wrote this in a completely rejected paper that that Faith and Philosophy did not want to hear. I have my own reasons that protect my ego for why that is. Yeah, this was counter to something Brian Leftow wrote, where he talked about two universes. He basically said, here's an arrow and two different timelines that come out of here. And so here's point S and here's point S prime. And S prime, that's supposed to be a prime, not a one. What you couldn't say, he's trying to say that there's no way to relate one to the other. So how do you know which one happens before? Now, what you can do is say something like this. If this is S naught, you can say S naught is related in time before S or before S1. And if you're going to justify some number of intervals, and you're going to say each one of these intervals runs the same in there, you could say there are 20 intervals here and there are 30 intervals here, in which case you have a way to say which one comes temporally prior. But there has to be an intersection point there. If there's a single event that kicks off all of these different universes, then the way you would say that is this multiverse had, every universe had a simultaneous initiation, but time could be running comparatively slower or faster from one to the other. But if these lines never touch each other, there's really no way to map one onto the other to say which one happened first in some meta timeline that's sitting out there. So if you want to get into that, that's philosophically just more challenging, because now you're trying to relate these multiple timelines together. But it's either this or, as you said, here's universe 1 and it expands and then contracts, and it gives you another try at universe 2 that expands and contracts. And this is called cyclic universe or bounding universe, or the different models of this have different oscillating universe. Yeah, there are variations on a similar theme that take a single timeline that you're running our universe is passed through. So when people are talking about the multiverse, that's typically not what they're talking about. What they're talking about is that in some way existing today are a bunch of other universes like ours, or some people will say our region of the universe, the observable universe, is but a small part, is just like of the dartboard, is this small little part. The rest of the dartboard is out there and is existing and expanding and contracting and all that kind of stuff. And that ours happens to be in a very low entropic state, comparatively speaking. But when you look over the whole thing, you're just like, well, that was just a region of entropic density that was low.
2 points. First, nobody really knows what the so-called initial conditions were. I mean, we just don't know. And it's not a problem to say we don't know. So if we don't know the initial conditions, anything that we say about what happens later on is just speculation.
If you apply that reasoning to any other part of science, you just destroy every other part of science. Nobody knows how life first came to be and what the first replicators were. So therefore, anything you say about evolution is just speculative. It's nonsense. It's not even science.
No, because we know what happened to it. We don't know how life began on this planet, but we know what happened to it after it got here.
I know, but what you said is, if you don't know anything about the initial conditions, you can't say anything about the rest of it.
I'm talking about the universe.
Yes, I understand that, but that's called special pleading, and it's a fallacy. So you can't do that. You can't say what's good for the goose is not good for the gander. If you're going to say it's science, then if you apply it to cosmology, you're going to apply it to evolution. If you apply it to evolution, you're going to apply it to chemistry.
We can say what happened at this point that we know about, just like evolution does.
Why do you think we can't do that about physics and cosmology?
I said, we can say what happens in this universe after this so-called Big Bang, but we don't know what happened before the Big Bang.
Sure, but this argument doesn't depend on what happened before the Big Bang. This argument actually works not only if you pick a spot here, you could pick this area right here and say this entropic condition is so highly organized that its improbability versus what it could have been is enormous. So it doesn't matter what happened before the Big Bang. This is talking about just what happened since the Big Bang. This is, in fact, only really talking about the stuff that we can observe. So remember, the light that we can see from the cosmic microwave background radiation that we can see, and the structures that we can see, all happen well after the Big Bang.
Yes.
After the Big Bang. Well after the Big Bang.
Yes.
Okay, which means it's not subject to the problem of at the Big Bang or before. In which case, your objection has no force.
No, before the Big Bang, at the whatever the initial condition was, which we don't know, there could be other branches coming out of that.
Yes, but we're saying forget about those, right?
How can you forget about it?
Because what we're arguing is the universe that we see right now is insanely improbable based on data that we can observe today and based on inferences that we can make that happen after the Big Bang.
Which brings to my second point.
Now, do you understand the point?
Yes, in this universe, but that doesn't rule out other universes.
Yes, but your objection wasn't about other universes. Your objection was that the fine-tuning argument doesn't work because anything that we say about what happens, we don't know the additional conditions, and if we don't know the initial conditions, everything that we're doing is speculation. That was your objection.
The objection was you can't say that the fine-tuning argument applies across all possible universes. But getting back to probability, your argument is based on the probability theory.
So this is a very important point. The fine-tuning argument does not say this is what happens across all possible universes. The fine-tuning argument says this is what happens about the possible ways our universe could have been.
Let's just grant that for the sake of argument.
That is the argument. You don't have to grant it. It is the argument.
Okay, let's grant it. I'm no probability expert. I know your wife is.
Yeah, but that doesn't make me a probability expert either.
But one of these papers I've got, the problem with the fine-tuning argument based on the probability theory is that I got to read this.
Yes, please do.
We're talking about the parameters of the cosmic parameters that have to be within a certain range in order for life to exist.
Yes.
Now this guy says, it must be, I don't know if it's true or not, the fundamental problem, how did the data, the premise says, the probability theory requires that this all be normalizable, and which means that everything must add up to 1.
Right.
And if you do that with the fine-tuning argument on these cosmic parameters, they don't add up to unity.
Why do you think that?
Because there's just too many of them. They add up to infinity.
So this is the what page are you reading from?
This is not from the paper. This is from the other paper.
Which one?
This is from one by Manson.
Yes, this is the one. This is the guy from the University of Mississippi, right?
He's from Mississippi.
Yeah. So remember I was talking about the dartboard?
That's another part of his argument. Yeah.
No, that's this right here. This is what I'm talking about. When you turn around and say it's not normalizable, that's identical to saying that that you end up with these singularities, you end up with these infinite points that are a problem mathematically speaking. The argument that I'm making for fine-tuning does not say when you throw a dart at the dart, we know the dartboard has a certain size, okay? So the fine-tuning of the argument says not there could be that the line of what the forces could be is infinite. That's not what it says. It says the weakest force we know of is gravity. The strongest force we know of is in the strong nuclear force type of stuff, whether those are unified or ununified. So these are the ranges of forces we could be. And what we say is, maybe gravity could have been as weak as gravity is, no weaker, but maybe it could have been stronger. Maybe the nuclear force could have been weaker. And how weak do we want to make it? Well, let's run it all the way over the gravity setting. And let's run the gravity one all the way up to the strong force setting. And we'll say that that represents the range. Okay, so now you've got a dartboard of a certain size. It's not infinite size dartboard, it's a finite size dartboard. Now, given that's the case, as you dial those things, and remember, this is even more than the entropy one. So entropy is a small version of this one. As you dial those things, how small is the circle? What the guy's saying, Dennis, in this paper is, well, like there's an infinite number of points on your finite dartboard. So the probability of hitting any point on that dartboard is 0, because it's 1 over infinity. But that would be true if you said this was a point. What we're saying is there's a range A range is similar in this dartboard thing to an area. So it's like saying I've got a bullseye of a certain size. It's a certain range. Given it's that certain range, I just say how big is this area compared to this area, and that gives me the answer. In the case of the low entropic condition, low entropy condition of the initial state of the universe, that ratio, the size of this area to this area, is 1 over 10 to the 123rd power. So that does not carry any force against the version of the argument that I'm bringing forward.
So
He does talk about this dartboard analogy of yours, and he resolves that.
He does not. He uses the dartboard analogy exactly wrongly. He says exactly the same thing I just said about there's an infinite number of points. He does not make the range point in that paper.
Again, I'm no probability expert. If anybody wants copies.
Yeah, feel free to read the paper and see where the truth lies.
Not to beat probability to death, but and not saying I believe in the multiverse, but your point is there's a lot of evidence for God, not a lot of evidence right now for the multiverse. But no, so Dennis would probably debate that, but for the sake of argument, let's just say that. But that being said, when we talk about a probabilistic argument, if we haven't completely disproven the multiverse theory,
Yes.
then is it disingenuous to use the term probabilistic? Because if the multiverse theory, if there's a chance it's right,
Yep.
it would claim that everything 10 to the 10 to the 123rd universes cook off simultaneously. We're the one that won,
Yes.
right? Therefore,
So in
since it's-
multiverse theory, why reduce yourself to 10 to the 10 to the 1?
Well, that's what I'm
You get
saying.
infinity. Like,
Okay,
it's
yeah,
going to
yeah,
happen.
right.
fair,
You're a
fair,
unit,
but in the multiverse theory, there's no probability because it all happens.
Right.
Right.
There's like nothing over anything. It's just everything.
Yeah, so I think what you do when you introduce multiverse, the point is you stop doing physics and you started doing metaphysics.
Okay.
And if you're going to make a metaphysical assumption, that by the way violates Occam's razor. So if you're going to turn around and you say something like this, a designer is possible, a multiverse is possible. Okay, now which one of the two, what's the probability a designer exists? Now this, by the way, was Bayes' project. Lest anybody forget, Bayes was a religious man and a pastor, basically, and he was looking to prove that God exists, and the Bayesian probabilistic system that we get now is the result of his trying to figure out how to prove God exists. And now, like, everybody's adopting this. It was slow to catch on, but in the world of statistics, the cognoscenti now that are going to sip their tea and look down on the other statisticians do Bayesian analysis. People don't do null hypothesis testing anymore, which we're still doing at CERN for some reason. In high energy physics, they're still using null hypothesis testing. But the Bayesian looks over the wall and is like, you guys are testing the hypothesis. You're not testing your hypothesis. You're testing the other guy's hypothesis. You're testing another hypothesis other than yours. How about testing your own hypothesis for a change? So that's the critique that Bayesian statistics levy on the quote unquote normal way of doing it. Yes, ma'am.
So this might be more detrimental than helpful.
Sure, fire.
But it seems like we're using this dartboard analogy when it might be simpler. Dennis, do you remember your calculus at all?
Remember what?
Do you remember integrals at all? I know it's been a long time, but
Sounds good.
do you remember your integrals, calculus?
I flunked calculus the first time around. Surely got it the second time.
So this might not be helpful, but whenever you do integrals, if you take, integrals are a really important part of probability. So whenever you are trying to determine the probability of one thing happening in an infinite range of possibilities, the probability is always going to be 0. So you never look at that. You always look at the probability that the value will fall between a range of values, like x from x equals 0 to x equals 1.
Yeah.
What's the probability of that happening? You don't integrate at a single value. It's just, it doesn't make any sense.
Right.
So whenever you're looking at infinite possibilities, I think what Scott's trying to say is, the probability of getting one thing is always going to be 0, even though, you will get one outcome. The probability, mathematically speaking, will always be 0. But you can determine what the probability is that you will get a range of values, because that's how integration and therefore probability works. You never, ever try to talk about the probability of one thing happening when you have an infinite range. Do you remember any of that from I know it's been a long time, but that's how you do integrals.
Yeah, but that doesn't, if there is a multiverse, there are virtually an infinite number of universes.
Sure.
So the fact that we live in one of them doesn't rule out other universes having different.
The only point I'm trying to make is I'm trying to articulate the dartboard analogy in more mathematical terms that I think are
more abstract terms.
More abstract terms that I think are easier to understand.
Yes, exactly.
It might be less helpful.
No, but the important part of the point that she's making is an additional point onto what she's making, which is, I think, extremely helpful, is don't forget that the math by which we're doing all of this has this as an assumption. Right? So when we turn around and say, well, look, when we are doing math that's part of the assumption. And so the fact that we can say anything about the world, is oftentimes is because of how we were mapping math to the world, and this is part of how that math maps to the world. I've got my truest way of arguing against some of these objections is to point out things like there's no such thing as an infinitely small dart. So even if you were only aiming at one point on a dartboard, your dart is going to hit an area. And this is, this goes all the way back to an ancient problem of concentric circles. Here's a circle with a dot in the middle of it. I can't make a dot with my finger, but you get the point. And here's another circle, and the circumference, of this one is twice what the interior one is. Okay, so if you draw a line from the center of it through this circle into that circle right there, is an interesting, the way that people normally look at it in this kind of Euclidean viewpoint, is any line that you draw, no matter what radius line you draw from these circles, there is exactly one point on each of the circles that it intersects. Now what that implies is the number of points. Now if you break these lines and you stretch them out, and this one's length 1 and this one's length 2, that the number of points on each of those lines is identical. Yeah. Which is obviously nonsense.
Hold on, I missed that.
So here are these two circles, right? We're going to cut them right here, and we're going to stretch them out. We're going to lay them out. So we're going to unroll our circles. You get these two lines right here. What this argument implies, it says if I draw a line from the center point of these two concentric circles, I'm going to hit a point here. I'm going to hit a point here. No matter how many times I draw this line, no matter where I draw this line, I'm going to get exactly one point for either side. That means for every point on the center circle, there's a corresponding point to the second circle, which means that I can map, and in fact that function is simple. It's if this one is, we'll call it, it's not y, it wouldn't range over it, but basically you can do one that says 2x. I'm going to map from x here to 2x here, and you end up having exactly one point that you can map to either way. And so people will say there's a bijection exists between these two. Because a bijection exists, by correspondence, they're identical numbers. The cardinality, the size of these two is identical. That's a problem. Yeah. Okay? Gauss looked at it and gave up on it. No, not Gauss. Galileo looked at it and gave up on it. We have since come, this is what Cantor was trying to do with his project, is explain the relative size of these cardinalities. I think it's all nonsense. I think the real thing that's going on here is, the problem is when you use the definition point, that concept is logically impossible. There is no such thing as a mathematical point. When by point, what you mean is a shape or a construct with a radius of 0. Because what I'll say is, per Leibniz, what's the difference between nothing and your point? Nothing's got radius 0, right? Nothing is just a name that you're laying on this particular location in space. If you can say it's a location in space, I'm fine with that. But don't say there's something at that location and that is a point. So when you start talking about points, the only thing that makes sense, and by the way, Leibniz and Newton came up with calculus because when you try to do this with anything that has these foibles of the infinite, you can't get an answer, or you're going to get something that's a very rough approximation. So they came up with this idea of limits. What's the limit that we seem to get to? And the answer is the limit depends on how many digits you're willing to accept, how many digits you want to work with. You can keep going forever on it, but that doesn't mean that at the end of it there's an actual point that exists.
That's the sort of the argument. Another way of looking at that is saying, are there potential infinities or actual infinities?
Yes, and so I happen to believe that only potential infinities exist, and that any process that generates an infinity is a temporal process. And since it's a temporal process to generate these things, nothing that doesn't exist in an infinite temporal timeline will yield you anything that is anything other than finite. But this is probably exceeds the scope of the class for now.
You run into crazy things like Hilbert's Hotel.
Yes.
Or to say, if there are an infinite number of points between me and the wall, technically, I should never be able to reach the wall.
Right, and so
but obviously that's just
these
absurd.
paradoxes,
And
in
so-
my opinion, all the paradoxes like this,
Yeah,
Thomson's lamp paradoxes, these are one of Zeno's paradoxes. Those kinds of things exist because we are making statements that are logically incoherent. We just haven't recognized that's the case. Yes, sir.
I was just going to say the points are different sizes.
Say that again.
I'm more in line too.
No, well, the thing is, the definition of point is logically incoherent. So that's like saying the square circles are different sizes. The correct way to look at this, in my opinion, is the angle. So this line right here is of a certain size. It's actually, let's say it is a set of dots. Well, each one of those dots has a certain radius. It's going to cross a dot here. A dot would have a radius. If a dot, let's say a dot has a radius. So it's got to be, it has to have, if it's going to be a dot, it has to have a positive radius. And then it's going to hit another dot here. Maybe it hits a dot here. It's possible that it hits, let's make these dots bigger, right? Because you can make this dot any size you want and just shrink it down as you go. But as you shrink that dot, you have to shrink these dots. Well, these dots touch each other. So it's possible it shoots between two dots, right? Maybe you tip it over this way and it hits one dot. But if it intersects anywhere in this dot, you'll notice that actually cuts an angle. So a dot is going to cut an angle, and this is where it gets resolved, is the angle. I didn't draw that properly. But the angle that this cuts right here is going to be half the angle is identical. The size of the line that it cuts, the arc that it sections, is half of the arc up there. And now sanity is restored, and you can reasonably say that there's a reason that the circumference of the second circle is twice the reason of the first. And all it is really just redoing Newton and Leibniz again, because that's the limitation of math. Yes, sir.
So, since we've talked about this science fiction, can we talk about my favorite science fiction, which is simulation universe? Because it's basically, you tell somebody multiverse and you go, oh, well, I believe the simulation. And they go, okay, I'll believe by that. And then you say, well, how's that different than God? Right, because they're basically the same. I don't think any of these arguments about probability and all the other stuff, I don't think they matter at all. They don't change anybody's mind. You know, you'll get PhD people who know probability. They'll twist themselves in a knot just to prove some nonsense. Little piece of it is wrong.
So this one we discussed when you weren't here. I will send you, send me your email, because I don't think I can text it to you. I've got a paper that I presented at MIT on this, that at a machine learning, human collaboration machine learning symposium or whatever it is. A bunch of presentations there. So I wasn't the keynote anything. I just put a poster up and did it. But it generated enough interest that I had 20 papers laid out, and they took it, and people were trying to take pictures of it. So it wasn't of no interest.
Okay.
That one makes the argument that simulation theory is mathematically impossible. And the reason it's impossible is laid out in the paper.
It's fiction, but my point is,
Except that this purports to prove it's a
my
fiction.
point is, there's a common way to argue with people who are into conspiracy theories, which are the hardest people to argue with, right? Because they're crazy, their thing doesn't make sense. I'm not saying that this is that multiverse. But
Why is either simulation theory or multiverse a conspiracy theory?
I'm not saying they are, but I'm saying there's a way to argue with the hardest people to argue
I got you.
with.
Yeah, okay.
Which is, you don't attack their main premise, you get them to see an alternative point of view that is possible. You essentially attack the edges of their argument. And when you can get somebody to say, somebody who says multiverse, they're always going to say that there is no fine-tuning, right? But if you can say, look, there's all these other people who say simulation or whatever, and
Let's hold on. You only ever say there's a multiverse if you admit to fine-tuning existing. There's no reason to posit a multiverse. There's scant reason to posit a multiverse otherwise. Like, why buy off on the metaphysical load of
I'm just saying that two essentially mutually exclusive science fiction arguments could be, like I said, I just don't think the probability, it matters, because no one's going to be changed their minds. I've argued with people who, for more of it doesn't come in as much with the universe, but it does come in with Darwin all the time.
Well, so yeah, and maybe it brings up this point. I think if I'm being the most generous that I can, maybe not even most generous. Let's say that this is an attempt to be objective. If you're willing to buy on the multiverse, buy it off on an unobserved, non-currently interacting, we can never detect it multiverse.
No way to prove it.
That's at best is equal to the hypothesis of God.
Right.
So why are you saying now the problem? There's a problem the multiverse has that God does not have. The traditional definition of God includes God being self-existent. Okay, so by the way, this is outside the fine-tuning argument. This is a further step. Now you're saying, okay, fine. This doesn't buy you anything. This buys the religious guy something. In that normally what people have said is the religious perspective is just ad hoc. I don't have an explanation for this one, so I'm going to bring in this metaphysical construct that I don't have any justification for.
Sure.
Well, the same thing has just been done with the multiverse.
Yeah.
So at a minimum,
Against the multiverse of the gaps.
yeah, the sword cuts both ways.
Right.
So now you say, okay, well, fine. Now you still don't know. It's 50-50. How do you know that's the case? Okay, well, let's look at the God hypothesis. God can. How about the before the singularity, before the universe that we exist, where we're getting all this information from? How about looking back before that one? Do we have any reason to think that God could exist before that? And the answer is, yeah. If we're saying God exists, and our concept of God allows this God to exist, He's self-existent. He can exist eternally. He can exist atemporally if He wants to. So here's this God that can exist unchangingly and self-existently. All right. So I guess that covers as far back as you want to go. What about the multiverse? Yeah, the multiverse could exist before the Big Bang too. Okay, fine. Is it self-existent? No, we don't have, and in order for it to be self-existent, it would have to be necessary. In order to be necessary, that means that this universe is necessary. You see what I'm saying? So, because it's not making a choice, there's no free will in this multiverse. So it's necessary, and now how far back can it go? That's the other question. Now you've got the philosophical arguments about how far back can a line go. All the philosophical arguments fall on the grounds of a line there can't be an infinite temporal regress. Right? There is no philosophical argument that I know of today that says, here's how you can have an infinite temporal regress and still be at this particular point in time today. That has been the reason for all these paradoxes that people have been trying to get around. There's no answer to that question on this side. So the problem is this side generates paradoxes. This side, you're like, oh, no, God's self-existent. That makes sense. Now, maybe you're still no better because the critic is like, well, you just waved your hand and said God is a necessarily existent being. Well, that's where the guy is going to have to turn around and point to an argument for why God would be necessary. So an additional argument is needed to justify why you believe that this God is in fact a necessary being, and that argument is called the ontological argument. There's no existing argument on this side that I know of that mirrors that, in which case you're going to grant an advantage to this side.
Materialism and say there's nothing outside anyway, so it doesn't even matter. They don't need a necessary argument because materialism is basically just that this is all there is and therefore...
But necessity is a very strong thing. Necessity doesn't say that something exists. So what it says is it has to exist and it can't fail to exist. And there's just nothing that says that material is that way. It seems conceivable to us. We can sit there and think, is it possible that no material would exist? Is it possible that nothing exists? And we could be like, yeah, I can conceive of how nothing at all would exist. Like that doesn't seem that far-fetched. So it's not necessarily true that something exists. Something material exists.
Would you agree that there is possibly non-expansion universes exist?
Yes, of course.
They could necessarily be past infinite.
I would
No.
disagree with that, yeah.
How are you going to make them? How are you going to give them an infinite temporal regress? How are they going to be at this point today if they had an infinite number of points that they had to cross in the future or intervals?
They are non-expansion universes.
Sure.
Then we don't know what they are.
Well, they would be either contracting or they would be static, right?
They could be past infinite.
Well, if they're static and they don't move at all, then they're atemporal. If they are contracting, then they are temporal, right? They're changing. If they're changing in time. So they're either temporal or they're atemporal. They're either expanding, contracting, or static.
They could be static.
Right. In which case they're atemporal. So it's not forever. They're atemporal.
Depending on how you define time, yes.
Yeah, absolutely. But I mean, that's a static universe. If you've got a clock ticking on the static universe, you have exactly the same problem of an infinite temporal regress. How did you get to this point? If you don't have a clock ticking, then you have the necessity and contingency problem. Does that universe exist necessarily? And if the answer is, yeah, I want it to exist necessarily, you have to ask, is it possible that that universe doesn't exist? It's possible it doesn't exist, and it doesn't exist necessarily. Okay, so now we are at 10, so let me take these last 15 minutes to point out where we sit and what it implies for us. Remember our project. Our project was start at 0 and figure out if there are good reasons to believe that God exists. And not only figure out if there are good reasons to believe that God exists, and the same thing, remember, starting at 0 means I don't know anything about God, I don't know anything about science. And so what we started out with saying was, how are we going to know anything? What we said we're going to know is we're going to use reason. You know that we're going to have to start with something like this, where if you can't justify it in some sort of argument, if you can't give a reason for it, it doesn't count. So I can't turn around and say, this point is true because unicorns. That's not a reason, okay? That was proper to laugh at, you're good. You have to say is the reason, and it has to make sense. So we can debate all day long about where it comes from, but at the end of the day, we agreed to this point. You have to be able to give a reason for it, or you have to be able to make an argument for it, or it has to be logically coherent. All that's entailed in reason. The second thing that we wanted to use was evidence. We agreed that we need to go with evidence past that, because as soon as you start using reason, you at least are like, well, okay, hypothesis, none of this exists. It's just me. And another hypothesis, it's not even me. I don't even exist, a la Buddhism, right? It's all is one, and it's all really nothing. It's all illusion. All the stuff we see is illusion. That really there's just one. Well, if there's really just one, then the statement, I don't exist, is false. So at a minimum, per Descartes, and really per consistent Buddhism, would be, I at least exist, because somebody's doing the doubting that I exist. That was Descartes' point. He was like, what can I not doubt? I can doubt that you exist. I can doubt that this exists. I can doubt I exist. Now, if I doubt I exist, then who's the I, and I doubt that I exist? All right, I have to exist in order to doubt that I exist. And so he realized that undermined the statement. So at least he exists. That's what he thinks. So if that's the case, see what he did is he looked for evidence. I've got a hypothesis. I'm using reason. I'm going to look for evidence. So that doesn't allow that to happen. So it's not allowed that I don't exist, but maybe all you guys are figments of my imagination, and I'm the only guy that exists. That's still, I got to look for further evidence. I got to make some assumptions. So we said reason and evidence is what we're going to stick in with. Then we said, okay, well, what evidence are we going to accept? Because we believe a whole bunch of things. We got a bunch of apparent evidence points. And what we said was we're going to use epistemology called properly basic beliefs, which basically means whatever belief you start with, you are justified in holding, you're rational to hold, you're justified in believing up until you encounter a defeater for it. So something like, I believe you guys exist, right? That seems reasonable to me. I'm going to hold on to that as a possibility, as what I actually believe. I'm going to assert that is true until I find, I come out of the matrix and realize that, that was all an illusion. Now I've got a defeater. The defeater is, here I am being unplugged from the matrix and washed down this toilet and picked up by this other hovercraft, okay? Now I've got good reasons to doubt that the world I was living in was in fact real. Real in the same way that the toilet world I'm living in is. So we've got these properly basic beliefs. That's going to be kind of our epistemology working forward. And we said, all right, now we've got a way to think, to evaluate, and to get material to use our thinking and evaluating on. That's what we did. All right, so this is neutral. Every religious person, every scientific person, every religious scientific person, every non-religious, non-scientific person, all those people should be committed to this kind of thing. Now, if they're not committed to this kind of thing, they've got to have a really good reason for not being committed to this kind of thing, and now they're stuck again, right?
Postmodernist.
Yeah, but which has failed.
Yeah.
Philosophically fairly badly. But you're right, that project was all about abandoning this thing, and it just didn't work. As I think Ravi Zacharias did say, even at the Postmodern Museum, where they have stairs that go nowhere and buildings that don't stand up, they're like, I bet you they didn't build the museum on postmodernist principles, right? So you got a little bit of a problem when you try to avoid reason and evidence. So we're going to do reason, we're going to do evidence. We defined what evidence was, and we've been using a Bayesian system, which is basically the probability of, well, I'll leave the equation out because it doesn't matter here, that basically the probability that something occurs given something else is greater if you have this something else than it would be if you didn't have this something else. That's a very rough, ugly way of saying what Bayesian probability is. And if that probability is higher, then that should be evidence for it. So a more practical example of Dan is laying in a pool of blood, and we think that it may be a murder. Okay, so we've got some probability that it's a murder, and there's Dan laying in a pool of blood. And what we say is, given that people are laying in a pool of blood, murder is 23% likely the case. That 23% of the time when you're laying in, or 4% of the time when you're laying in a pool of blood, it's because you were murdered. And then you turn around and say, okay, well, I want to figure out if there's evidence in this case. And so 2 pieces of data are brought forward as evidence. One of those pieces of data is there's a microphone sitting right here. Okay? The second piece of data is Scott standing here with a smoking pistol. Okay? Now, what's the probability that Dan was murdered if he's laying in a pool of blood, given that there's a microphone here? Does that increase the chances that this was a murder at all? I think not. Smoking gun. Does this increase the probability that he was murdered? Now, that's not a lock, right? There's a number of reasons I might have a smoking gun. I might have shot at the murderer. I might have come in and found the smoking gun and unwisely picked it up and gotten my fingerprints on it, being like, I wonder what happened here, right? So there's a number of things that could be, but does that increase the probability? Would that then be evidence that I killed Dan? And the answer is you bet it would. I got a lot of splaining to do if I'm holding the smoking gun that killed Dan. All right, that's what Bayesian probability does. It's what is the probability that Dan was murdered given this bit of data? And if the data help establish the hypothesis, then that counts as evidence for that hypothesis. That's what evidence is. That's simply what it is to be evidence. Then what we did was turned around and said, let's look at a number of things to help us figure out basically who's right. What should the default position be about God? And we didn't just say we're asking the question about God for no reason. You may remember that we asked the question about God for a very specific reason. Why do we ask the question about why does God exist? Why do we care? Right? We've got this powerful system for figuring this stuff out. Why do we care? What are we going to use it for first? Right? You got the world's best digging tool. What's the first thing you dig for?
Gold.
Right. So something valuable. And so you want to say, what's the valuable thing after which I want to dig? So what's the most valuable thing you can dig for? So what is it that we all really want? We want to be happy. We want to be happy for as long as we possibly can. Which means that we're going to investigate 2 things. Happiness and immortality. Right? If immortality is a thing, let's imagine for a second that like X-Men or Marvel superheroes or whatever, that we have good reason to believe that there exists some element on Earth that if you take it and distill it and you drink it, will make you immortal. What is everybody on Earth doing at this point? Wars are breaking out over places where this immortality thing is to be mined. Everybody stopped doing anything other than food production and building immortality element seeking devices, right? I mean, that's an exaggeration, but that's basically what we end up doing. If it's the case that it's reasonable to believe that, right? And why would it be reasonable to believe that? It might be because a number of people watched somebody say, yep, hey, this stuff works, worked on it in a lab, drank it, and then lived forever, right? That would be a good example of that one, which, by the way, is the Christian narrative, right? The reason that you would investigate this, one of the reasons you would investigate this is the Christians are sitting being like, yeah, there's an immortal element out there. It's crackers and bad grape juice. And if you have crackers and bad grape juice the right way, immortality results, right? A little tongue-in-cheek, but you get the point, right? Christianity is claiming not only can you be immortal, you can be immortally as happy as you can possibly be. So it's at least it's something to at least look into, however briefly, right? And Judaism the same way, right? Judaism, slightly different formula, but the same result. The idea is, at least in modern rabbinic Judaism, where eternal life is a thing. That's about immortality and happiness. It's not an immortal, unhappy life. It's not a finite life. It's an immortal, happy life. It's the same goal. So those are worthy things to look after, unless you just think that the idea is so preposterous, like it couldn't possibly be true. But isn't it worth, like, I don't know, a week looking into? You got 80 years or so. You got 20 years. Spend the week figuring out if that's true. Might not be. It'd be worth your time if it turns out to even possibly be true. So that's what we're going to investigate. That's the reason for looking at whether God exists or doesn't exist. So now we're going to say, all right, fine. But my test for looking into God is not walk into synagogue, walk into church, listen to songs, and then listen to dude talk about it. That's somehow going to tell me for certain whether this God exists. Like, I may hear data in there that now I can say, these are data, I'm going to use my evidence test to see if this is evidence that God exists. But what's the best way to do it? Well, fortunately, people have been doing this for a few thousand years. And the answer is they've come up with arguments for this one, right? So arguments for the existence of God and arguments against the existence of God are ones that we want to look at. So arguments for the existence of God, we basically made 3. But we'll look at these following statements, okay? Now the statements that were made are ones that we want to look at as though we don't care whether the religion stuff is true, whether we don't care if the a-religious stuff is true, right? We're supposed to be coming at this with a zero prejudice. So if we imagine ourselves actually coming up to this with zero prejudice, and we say things like this, things that exist, and I'm just going to put an E, things that exist had causes. Excuse me, things that begin to exist have causes for their existence. Okay? Now, is that reasonable or unreasonable to think? Things that begin to exist have causes. Well, let's assume that it is, right? Well, what's based on that? Science is based on that, right? If you don't believe this principle, you don't do science. Because science is about, I see this pattern happening, and I'm looking for the cause for the happening thing. I see a phenomenon. What's the cause? What's the explanation for it? That is what science is. So if you deny one, no science allowed. Point 1. Point 2, if things that begin to exist don't need causes, then what's the explanation of why things aren't just popping into existence all the time? Why is there not a unicorn here? Why is there not beach ball here? Why is there not food instantly on your table? If they don't need a cause, how come it's just not popping into existence all the time? Okay, so some of those, this seems to be like not just fairly reasonable, like kind of almost smack yourself on the head, duh, yeah, that's true. Okay, how about this one? The universe / multiverse began to exist. Okay, that's believed by, I made the arguments for who believes that and why they believe that, but that's the canonical position of cosmology today, is that the universe had a beginning 13.7 billion years ago. Right? That's what's in all the textbooks. So if you're going to take the standard scientific position, that's the position that you go with. Okay, how about this one? Objective morals exist. Okay, this means Nazis don't get to say what's right and wrong. Even if Nazis conquered the whole world and they said it's right to kill whoever we want, they're still wrong. That's what an objective moral is. If you believe that, then you believe objective morals exist. Okay, how about the universe, the one that we see, is either by chance, necessity, or design. And it's not necessity, so it's either chance or design. And chance plus what we observe equals 1 over 10 to the 10 to the 123rd. Okay? Now, if you take just this list of stuff and you say, where's the reasonable side on this one? Okay? Now you're going to break this into a checkmark system. Okay? Of like true or false. And It just happens to be what you believe is the most reasonable. Do you think it's more reasonable to believe that things that begin to exist have causes? Or do you think it's more reasonable to believe that things that begin to exist don't have to have causes? They can just exist for no reason. Which of those is more likely to be true? Well, I think fairly obviously that's almost certainly true. The universe began to exist. Well, remember what Hawking said. All of the evidence of modern physics and cosmology is that the universe began to exist a finite time ago. Okay, so of the two, it's possible it's false, but the scientific evidence is on the side that it's true. Objective morals exist. Now this admittedly is something that you're going to have an intuition about. But as you think about this and you say, is it possible that there's a universe? Imagine a universe where not just the Nazis, the worst people that you can imagine, worse than Nazis, people who tortured and killed people for fun. Like that's what they do. They go to the worlds in order to enslave them, not because they need the resources, they don't need the resources, but because they like torturing and killing other beings. That those guys take over the whole universe. Now take that universe and compare it to a universe where the most peaceful, loving possible creatures propagate throughout all the universe and they exist in perfect love and utopia. Compare those two universes, and if you think one of them is morally better than the other, you probably believe in objective morality. Okay? So which of those two is probably true? I'd say it's probably true.
Practically the other one's better because eventually these guys are going to run out of people to kill them. They've killed each other.
Sure, but at the end of the day, which one's morally,
Well, okay, yeah,
if you're going to say morality exists at all, you've got to say the second universe is better than the first. No matter what the people in the first universe say. How about the universe exists from chance, necessity, or design? Yeah, that seems to be probably true. We can't even think of another one. And that chance is so low that given, if you say something like, chance, odds of a God existing are even 1 in a bazillion, that's still way, 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 way more probable by orders and orders and orders of magnitude than the possibility that the Earth, that the universe that we see exists due solely to chance. Unless you're going to bring in a multiverse that, again, you can't establish its existence at all because it's neither necessary nor can it be infinitely regressive. So what I want to point out is, without being a Christian or a Jew or a religious person at all, at first blush, if you just use these things fairly, all of the check marks are on the side of the premises of the arguments that give you, therefore, remember the conclusion of the first argument was, therefore, a non-spatial, non-temporal, immaterial, enormously powerful personal being exists. Right? That's what the first two give you. The second two give you, if God does not exist and objective morals do not exist, objective morals do exist, therefore God exists. So your deductive conclusion so far is a cause for the universe that is immaterial, powerful, and personal, and God exists, and a designer exists based on what we can empirically sense about our universe. These are the three conclusions that you get, and they're not three attendantly good conclusions or arguments against it. If that statement is true, then what you ought to do, everybody's position at this point ought to be, well, it looks like, based on everything that I know, God almost certainly exists. That should be the going in position. And from there, that ignores the fact that most people already properly basically believe in God. The vast, vast majority of people, over 95% of people worldwide, over 98% of people worldwide, I think it's over 99% of people worldwide, believe that a God exists. So that's, from a basic belief perspective, that should be your starting point. But if it's not for you personally, when you look at this kind of stuff, all of the evidence from what we've looked at so far are for it. Now, what I would like to do next, what I would like to have done next, is gone and looked at the arguments against God's existence. And I'm happy to do that if we want to start biting on that a little bit. The problem with that is, I will admit to, I've never found one that I think even passes the giggle test. And if that's the case, then the best thing that I can do is turn around and say, well, popularly speaking, these are the ones that have been raised against, guys like Bill Craig have debated. These are the ones that at least made it up to Sean Carroll believes it, or Richard Dawkins believes it, or some of these popular figures believes it. But that's hardly a great way of making of figuring out what the best argument is, because we don't want to argue against the weakest arguments. We want to pick the strongest opponent's arguments and argue against them. So part of me is a little bit reluctant to do the project because it's just going to feel like I'm sitting here building up a straw man just to knock it down, right? So, and because, I don't want to put such a burden on Dennis and be like, okay, Dennis, January, it's you against everybody. That's not fair either, because Dennis is an acknowledged not an expert in a lot of this stuff either, so it's not fair to him. So, and in short, what I would like to do is this. Please, on your own, for the course, I'll give you time to do this, but we'll do some other stuff in the meantime. Over the course of January, go and find the best possible arguments that you can find, or the best arguments that you can find against the existence of God, and let's treat them here. Okay, so I'll open it up, and if nobody comes back with anything, I'll at least give the ones that were taken up against the popular level. You may remember Sam Harris once said, he got a lot of calls before his debate with William Lane Craig, and he said that Dr. Craig was the one guy who put the fear of God in him and his fellow atheists, and tongue-in-cheek, of course. But what he was saying was, this guy represents some of the best opposition that we have. And so some of the best opponents likely would have been drawn to him, so I will at least treat some of the arguments that were done there. Has anybody got anything they would rather do, let me know.
Any atheist will tell you that they cannot prove that God does not exist. You can't prove a negative. That's what most atheists will tell you.
Most will, but there are a few who have tried to,
That's
right?
what I believe.
Yes.
You can't prove a negative. Atheists will tell you that we don't believe in the existence of God because we don't see any valid evidence for God. Which brings me to your point about these arguments that you're making. You and I both know Oz Guinness.
Yes.
He's an evangelical Christian. He's written 36 books on many different subjects. The guy's brilliant. Right?
From the Guinness family, the Guinness beer family.
His great-grandfather founded the Guinness.
I didn't know that. That's cool.
And you will admit, Scott, that he is a brilliant man.
Yes.
He puts absolutely no stock in these arguments that you're making here. He calls them board games.
Yeah, but do you remember why?
Because that's what they are.
What he says is he doesn't see them as effective at convincing people like yourself.
Yeah, that's my opinion too. He says they're board
Yes,
games.
he emailed us on Tuesday and said exactly that. Go back to the Tuesday email and he said exactly that. So read his email again, you'll see that's his reason for it.
That's absolutely my point. I don't think they have any effect on other people. It doesn't mean they're not true, right? I just don't think the number of people you're going to sway to the other side with probability and.
Now, well, let me bring this up in my wrapping it up because I'm past time. Dennis, do you agree that this is the way that you should evaluate truth?
Agree with what?
That this is the way you should evaluate truth, using reason and evidence against some set of beliefs?
Sure.
Okay. Do you agree that these things are more probably true than they are false?
No.
Okay, do you have any reason for believing that they're not more probably true than they are false? Can you give me an example of one reason that you think that things that begin to exist do not have a cause?
Next time.
Okay. And that's what we need to do is look at these and say, why don't we let you treat some of these next time? But if you can, we have spent the last 5 months giving you an opportunity to do that. And so this is why I don't want to put the burden on you.
Going down this path privately and made my case.
Yeah, I agree. But that doesn't equal that you have good reasons for believing these are false. So as an example, on the first one, you tend to appeal towards to say that the fact that atoms will time out and basically decay, that those are uncaused, and that's simply just not the case.
Yeah.
And you've pointed to a number of phenomena like that because we don't have at present a deterministic explanation of exactly how they work, that somehow equals that they do not have a reason for beginning or ending their existence. So that's it. That's all you've ever given me counter to that.
No,
Give me, in the limited time you have, just give me one example.
We better just get out.
next time.
Okay, next time we'll do it. And so I think that you see the point. Oh, sorry. You think that you see the point? The point is the default position ought to be this. And if you're not, then you need very, very good reasons for disagreeing with these. All right, we will see you next time. Thanks very much for your time. Sorry for running over.
It was so short. I worked a lot.
Oh, yeah.